Hello everyone, myself Arshit Naveen. This is part 2 of implementing and prototyping a 4x4 multiplier using Quartus Prime IP generator. So in the part 1 we had shown the result, we had displayed the result on the LEDs, but in this part 2 we will be displaying the result on 7 segment display. The steps are similar to the part 1. Need to create a new project wizard, assign a proper working directory, view the name for the project, then click a proper device for that. It's done. Just once all the steps are done, then just finish. Now it's creating the files. So it has opened the project. Now let's go to the IP catalog. Under IP catalog, under the library again, basic function, arithmetic. So LPM MULT is the multiplier IP. Select, give a name. I'm selecting Verilog because I'm comfortable with Verilog. Press OK. Since it's a 4x4 multiplier bit, so let's change it to 4. And as you can see, the result bit is also changing. Then 4, now it's 8 bit. Once it's done, let's go to next. This is the default. If there is no need to change in this session, this is also default. In this, you have to select the generate netlist, then go to next. So in this, since I am using Verilog, I will be selecting the Verilog HDL black box file and the prime symbol file and instantiation template file. I'm not selecting the VHDL and HDL file since we don't require it. So now it's creating the IP. Select S. So here you go. So this is the IP generated.p file, but since we will be using the binary, right? So you have to convert the binary to the decimal value. The code, we need to modify the program since we will be using the 7 segment display. This is the modified code for the 7 to display on the 7 segment display. So this is the top module where I have instantiated the multiplier and the conversion from binary to the decimal, and this is the 7 segment encoded display. This is where I will be assigning the 7 segment like zeros, tens and hundreds. This is where the exa value will be displayed on 7 segment, and this is the IP generated code. Once you have programmed it, you need to again compile it from first. Once you're done with the compilation, again you will have to go to the analysis and synthesis part, then compile the IO assignment analysis. Once you've done that, you need to go to the assignment and pin planner. Over here I have assigned the input and output of the hexadecimal and the input by referring to the datasheet of the FPGA board. You need to assign the pins and of the input and output by going through the datasheet of the FPGA board. Once you assign the pins, inputs and the outputs, you need to make sure to attach the STC file. This is in order to generate a new STC file, go to file, new. So this is where you will find the synopsis design constraints file. Once you're done with that, you need to compile the entire design. Once you're done with the compiling of the entire design, you need to program the device. So this is where you will get the programming of the device. Since I have programmed the device previously, you can able to see my device is already in it. You have to select, then press start. So here you can see that it has been successfully programmed. Now let's see the outputs on the FPGA board. So this is my FPGA board where it's the inputs are assigned to the initial 4 switches and the last 4 switches. So here you can see, so this is a 7 segment display. Since we will be multiplying 4 cross 4 bits, so 15 cross into 15 in decimal is 225. So I'll be requiring three 7 segment display. So when I turn on all the 4 switches from both the inputs, the output is 225. Similarly, if I want to get like 81 the output, so I need to make sure it's 1001 into 1001, I'll be getting 81. So similarly, if I want to get like 36 as an output, one zero one zero zero 4 into 9 is 36. Now let's do the 5 0101 1001 45. So by this we can conclude that we have programmed the FPGA board correctly and we can see the output on the 7 segment display. Thank you.